plastic containers. So you don't actually get to do Lab 10 today, because we don't have Petri dishes for you to do it into, put your stuff into. But we're still going to talk about it. It's called dry labbing. We're going to walk through it as if we were doing it, okay, and talk about the results that you're going to get, because I don't want you to mix the material, so you don't actually get to do it today. So, Lab 10, this procedure is called a viable plate count. Viable because we're only going to be concerned with the bacteria that are alive, right? That's viable. They're living and able to grow. Plate count, right? Plate means Petri dish. And count, we want to know exactly how many bacteria, or as close as we can get to exactly, are in a stock culture. That's the purpose of a viable plate count, to get a number, an actual count of the number of bacteria that are alive and able to grow in the stock culture. So when you got a tube from me that was turbid, okay? We're trying to find out this nice turbid, cloudy tube, how many bacteria are in here. That's the purpose of the viable plate count. How many of them are still alive? You could suck up with the pipette a little bit of this and put it under the microscope under oil immersion and count how many bacterial cells you see. But you're going to be counting living and dead ones, right? Under the microscope, if it hasn't decomposed yet, you can't tell if it's alive or if it's dead. So if you were to do a direct microscope count, you'd get a number that was too high, right? Because you'd be counting both living and dead. So we're not going to do microscope counts. We're going to do viable plate counts, where the only ones we're counting are the ones that are alive and able to grow. Now, we can't just take a milliliter of that stock culture, that turbid stock culture, which probably has 1 trillion bacteria in it, and plate it on a Petri dish and get colonies like that are in front of you, right? If we took a mill of stock culture and put it directly on agar, there'd be so many of them in there, they'd cover the whole surface, right? There'd be no way that you could count colonies. So we're going to have to do dilutions again, just like we did in Lab 9. We're going to have to reduce the concentration. But this time we're going to be doing quantitative dilutions. In Lab 9, with those pour plates in front of you, you use the loop, right, to move the bacteria. You didn't know how many bacteria you were moving. How many's on a loop full? Right? Depends on how big your loop is. This time we're going to be a little more scientific about it. We're going to measure the amount or the number or at least the volume of bacteria that we're moving. So quantitative dilution, we're measuring the amount of liquid we're using to make the dilution. And dilution is still reduction in concentration. So for this, you're going to use a pipette, and a sterile one. If you guys had that first lab where you had to bust it out of the plastic, right? It's sterile. You would take a ml of liquid, 1 milliliter, and move it from the stock culture to a bottle called a dilution blank that has 99 mils of sterile water in it. Dilution blank is just a bottle that's got 99 mils of sterile water in it. Got one back here to show you. Snake my way through. Here they are, glass bottles. They've been filled with 99 milliliters of water and put in the autoclave to be sterilized. So that's your dilution blank. So you're putting 1 ml of stock culture into 99 mils of water. What's your total volume now? 100 mils. 100 mils of total volume, and how many of those had bacteria in them? 1. So you've got 1 ml of bacteria and 100 mils of total volume. And if you were to do that math, take 1, divide it by 100, you'd get 0.01, right? You can check me on a calculator later. And if you know scientific notation, if you were going to write that number in scientific notation, it would be 1 times 10 to the minus 2. So we're going to call this the 10 to the minus 2 dilution. 10 to the minus 2 means 1 over 100. That 2 tells us that there are 2 zeros in the denominator. That's all it means. And we just made 1 ml of bacteria and 100 mils of total volume, so that minus 2 means 2 zeros on the bottom. 1 with 2 zeros. You'd mix it up, right, to distribute those bacteria. Get rid of that first pipette because it was in the stock culture that had 1 trillion bacteria in it, so it goes in the biohazard bag. Get a clean pipette, a sterile one, and now move a ml of liquid from that first dilution into a second dilution blank, a second bottle, sterile, has 99 mils of water in it.
So don't go back to the stock culture.
Don't go back to stock culture. We're doing serial dilution here again. We're using one dilution to make the next, just like we did in Lab 9. So, this is the 10 to the minus 4 dilution, because we've done 100 mils twice. Right? We moved 1 mil into this dilution blank, shook it up, get a new pipette, move a mil from this dilution blank to that one. So we've got 2 sets of 100. 10 to the minus 4 dilution would mean 1 over 1 with how many zeros? 4. We just made a 1 in 10,000 dilution. Does that make sense? We did 100 twice. Mix that up. Then you throw out that pipette, get a clean, sterile one, and do it again. Take a ml of liquid from the 10 to the minus 4 dilution, put it in a third dilution blank. This has got 99 mils of water in it as well. So we've got 10 to the minus 2, minus 4, what's this one going to be? Minus 6. And that would be 1 over 1 with 6 zeros. Right, that's what the minus 6 tells us. That's telling us how much we've diluted it. We diluted it 1 in 100 here, 1 in 10,000 there, and now we're up to 1 in 100,000 here. A million, actually, 6 zeros, 1 in a million. Now, we're guessing that by the time we've diluted it this much, we've taken that original mill of stock culture and diluted it all the way out a million times, we should be able to put it on auger and see isolated colonies like you have in front of you for Lab 9. It should be dilute enough now that there's enough space we can see them. So we're going to take a ml of liquid from this dilution, the water that we've just diluted with bacteria, and put it onto a nutrient auger plate. It's just plain old nutrient auger. And we're going to make duplicates. We're going to do it twice. We'll put a ml of liquid onto one nutrient auger plate, put another ml of liquid from this container onto a second nutrient auger plate. We always make duplicates in case something goes wrong with one, we've got a backup. Spread out the liquid, you're just pipetting the mill on, spread it out, and then stick both of those in the incubator. Now, we could have guessed wrong. There may still be too many bacteria in here to see isolated colonies. They may cover the whole surface like your tube 1, right? You wouldn't want to try and count every single dot on your tube 1 Petri dish. Right? That may be what happens here. So we're going to dilute it further. We're going to get 2 more nutrient auger plates. And instead of making a separate bottle that we call 10 to the minus 7, we're going to cheat a little bit and use this 10 to the minus 6 dilution. Instead of plating a whole mil like we did here, we're going to plate a tenth of a mil, 0.1 mils.
And we measure that with the pipette?
Mm-hmm. Yep, you've got pipettes small enough to measure a tenth of a mil. And you put a tenth of a mil into one nutrient auger plate, make a duplicate, a tenth of a mil into a second nutrient auger plate, and label them as the 10 to the minus 7 dilution. Because they're just 1 decimal place off from the 10 to the minus 6, rather than making up a whole new bottle for 10 to the minus 7. And then again, we're guessing here. We're not sure where we're going to get the right amount of isolated colonies that we can see. So we're going to make 1 more dilution. We'll go back into the 10 to the minus 6 bottle. That was a mil of liquid there. Move 1 mil of liquid from the 10 to the minus 6 dilution into a new dilution blank. 10 to the minus 8. This is going to be our last one. Mix it up. And then get a brand new pipette, because that pipette just touched 10 to the minus 6. We got to get rid of it. Get a brand new one to stick into 10 to the minus 8. And we're going to plate that. 1 full mil of liquid, again, duplicates. A full mil into this nutrient auger plate, a full mil into that nutrient auger plate. We'd spread it out across the surface. And they all go into the incubator. 18 to 24 hours, 37 degrees Celsius, just like everything else we incubate. Because we're guessing that when we pull them out of the incubator, they're going to look like your tube 1, tube 2, and tube 3 in front of you. That 10 to the minus 6 will look like your tube 1. 10 to the minus 7 will look like your tube 2, and 10 to the minus 8 will look like your tube 3. Are we wrong sometimes? Yeah, sometimes we do this and we don't get any growth. We should have plated this one, right? Sometimes the 10 to the minus 8 looks like your tube 1. It's so covered with bacteria we have to dilute it even more to get isolated colonies. But this is a good average to start from. Everybody follow what we did with the serial dilution there, using one dilution to make the next, and it's quantitative because we're actually measuring how much liquid we're moving, 1 milliliter of liquid. Any questions so far? All right, after you get it out of the incubator, come back the next day, pull out all of your plates. You gotta pick one to count. Remember, the goal of all of this is to figure out how many bacteria were in that original tube, right? How many were in that stock culture. So you've got to choose a dilution to count. You want to pick one that just visually looks like it has between 30 and 300 colonies on it. So looking at your lab 9 plates in front of you, which plate do you think has between 30 and 300 on it?
Second.
The second one, right? So you look for a plate that looks like your second one. You don't want to pick one that looks like it has 31 colonies on it, because it's easier to count 31 than 300. You want to shoot for one that's somewhere in the middle. So you're choosing, looking at your 10 to the minus 6, minus 7, or minus 8 plate, which one looks like it has between 30 and 300 colonies on it. And let's just say that you chose, for the sake of argument, 10 to the minus 6, right? Just so we can do an example. Then you actually have to count them. Yes, every little dot on that petri dish. Okay. A lot of people take a fine magic marker and make a dot on each colony as they're counting them, so they know how many they've counted. So aren't you glad you don't have to do this? You don't have to count, but that's what you would do. You literally count every single colony on both plates. Okay. So you made 2 duplicates. You've got to count each bacteria on each plate, and then average them together. Add those 2 numbers and divide by 2, right, to get an average from both plates. All right, so let's say that you were to do that. Let's do a practice one here, because this is what your quiz question usually looks like. And actually, your lab practical exam question 2. The student in lab did a viable plate count. They counted the 10 to the minus 6 dilution, and they found an average of 167 bacterial colonies. On a practical, you don't have time to count 167, right? So I'll give you the number. Somebody counted for you. They got an average of 167 colonies on the 10 to the minus 6 plate. What that tells you is that there were 167 colonies in this ml of liquid that you put on that plate. Right? So that's all the bacteria you put there. That's wonderful, but we want to know how many bacteria were in the original tube. So now that we've got this number, we have to work backwards with the math to figure out, it's not that bad, to figure out how many bacteria were in the original tube. Okay? So when you actually do that count, that tells you how many bacteria were in the 10 to the minus 6 dilution per mil. You gotta follow that? Because you pipetted a mil of liquid from the 10 to the minus 6 dilution, there were 167 bacteria in that mil. So to work the math backwards, to figure out how many were in the stock culture, you're gonna take that average and multiply it by the reciprocal of the dilution factor. Sounds worse than it is. Okay? Dilution factor. That's 10 to the minus 6. Right? If you had chosen the 10 to the minus 7 plate to count, it would have been 10 to the minus 7. Right? It's whatever plate you counted. So remember, 10 to the minus 6 in fraction form means 1 over 1 with how many zeros? 6. So we need to multiply by the reciprocal. What does that mean in math? You flip the fraction, right? This is the dilution factor. So to flip it, 167 times the reciprocal, and anything divided by 1 is itself, so you can just leave that off.